Assalamu alaikum. Bismillahirrahmanirrahim. We're discussing the Juniper certification. Certification track is service provider, and we're discussing one specialist level certification that is service provider routing and switching specialist JNCIS-SP. We have already completed the section. Number one is routing and switching. Third one is MPLS. So in MPLS module, we have discussed the RSVP and configuring a basic LSP, module 6 in last class. Today we discuss RSVP, the traffic engineering database. Okay, so let's start. And our topology all lab will be previous one. Okay, so let's start first. So our topics is the traffic engineering database, that is TED database. There is multiple section here, basically 4 section, and last section is live. Okay, so here we discuss how to deploy traffic engineering database in IGP. It can be ISIS or it can be OSP. Okay, and using the traffic engineering database, when we create LSP, we can define the traffic engineering path. And this path you can define in 2 ways. Number one is loose, and another one is straight. Okay, so let's start. Using ISIS to populate the traffic engineering database. When your IGP is ISIS, intermediate system to intermediate system, you can enable traffic engineering database under the ISIS protocol. And this is the terminology which is used in MPLS. We already discussed is one. So let's start now. See here, the topology is this. So in my topology, my link to R2 is gold. That means router 1 and router 2, that is 1 Gbps link. My link, that means R6 is silver, 400 Mbps available. That means they are telling R6 is silver. That means R6, which one is R6? This is R6. That is silver color, and the capacity is 400 Mbps. Capacity is 400 Mbps. So I want to send packet from router 1 to it can be router 5 or it can be router 10. Okay. So TE extension enable was pay for ISS to advertise extra information, text on links, link colors, or admin groups. You can enable admin groups under the interface. Basically, this engineering is admin groups are basically coming in CSPF, constant shortest path first technology. Today we discuss not the admin groups. We will discuss simple LSP where CSPF will be disabled. LSP can avoid or only use the links. Enhance bandwidth visibility, total reservable bandwidth, total available bandwidth. So more the processing is that we want use underutilized link. That means traffic engineering. Want traffic engineering. Okay, we want to deploy traffic engineering. So this is the sample configuration of ISIS. See here, under the configuration, edit protocol ISIS, interface is enabled here. Interface is enabled here, ISIS. Level 1 is visible here, white matrix used here, and they're using the reference bandwidth. This is the basic configuration of ISIS. Okay. There is no additional concept or configuration here. So ISIS traffic engineering verification, how to verify. So show ISIS database. Show ISIS database. The database name is R2. It depends on neighbor host name. I'm checking from router 1, and we want to check the database which comes from router 2. So the command is show ISS database are too extensive, and this is the detail command out. Here, important thing is ISS extended neighbor, that is R1, and the IP address and the neighbor IP address, and there is the reservable bandwidth formation. And here administrative groups. We are yet not configure any administrative groups here. And this is the default. Okay. So the traffic engineering database, just consider here. T info is extracted from OSPF and ISS. Reformatted for consistently regardless of the search protocol. Imported into database called the TED database. Every router has an almost identical TED like ICP, OSPF or ISS. Okay. So next, show TED database. So TED database, basically you can compare it with the ICP database. Similar information is stored in TED database. Okay. Show TED database. This command will show you the database details. The database details. Okay. TED database. When you show you any specific neighbor TED database information in detail, so you can use this command. Show TED database extensive and the neighbor host name. Okay. Show TED database. When I'm checking from this router, my neighbor router is router 1 and the neighbor router is router 2. The show TED database will be show TED database router 1, show TED database router 2. This is the command for verification of TED database. What additional information do ISIS and OSPF protocol advertise when traffic engineering extension are turned on? A special TE metric, and another one is a breakdown of available bandwidth information by priority level. Tags added to the links. These three information will add it when checking traffic engineering extension or when you configure traffic engineering extension. What key advantage does the ISS startups offer? The actual host name of the neighboring router. No need to memorize the neighbor IP address. You can check using the host name. So which component in the given output displays tags that are added into a link while verifying or viewing a router's ISS link step reading. This is the command show ISS database. The neighbor database neighbor host name stands. See here is the enter output here, and which component in the given output displays tags that are added onto a link while viewing a router's ISS link step reading and administrative groups. The administrative groups. Configuring an LSP that uses a traffic engineering database. Now we configure the LSP level switch path that use traffic engineering database. So in this section, we move to under MPLS protocol and set. This is the previous sample configuration level switch path, the path name and the destination. And here we use no CSP. No CSP is configured here. So need to, and there automatically discover enter path, which path will be select for traffic forwarding. Okay, and this is the record route. Okay, so if we want traffic engineering, that means we want send packet. We want send packet using the underutilized path. In that case, we want to make sure, or we want to we need to modify the record route. If we to modify a record route, then your traffic. Okay, let's start. We are discussing about record route. So how to set the path, how to modify this path. See here, this one example, explicit route. We can set next hop. We can set next hop in two ways. Number one is straight and another one is loose. So straight means this is directly connected. Straight means you have to define the neighbor which is directly connected. And another one is loose, that will be remote destination. And for this remote destination, backend protocol will responsible which path will be the best. Okay, or which path will be chosen. Okay, so this is the two variation. One is loose method and another one is straight method. I will show you both method in our lab. So now we're in question and answer section. Oh, number one question is which command displays the computed ERO information? Show MPLS LSP detail, record route information. Okay, that is very important for traffic engineering understanding. Which algorithm calculates the path for traffic engineer LSP? CSP basically used to calculate the traffic engineering path. So without CSP, it can be configured or it can be traffic engineer, no issue. So number one, LSP, level switch path, loose and straight hops. What is the meaning of loose and what is the meaning of straight? So number one, say here, hops in an ERO can be straight or loose. So this is my next hop. This is my next hop, and this next hop. See here, see here. So consider this output this output is coming from router one. Okay. So when it's sending packet, router one to router 6 instead of router 2. So this is the direct neighbor. If you mention the direct neighbor, you have to configure straight mode. If you want to go router 7 loopback, from router 1, so you can define here loose mode. That means router 1 will select the base path to go to the router 7 loopback destination. It can be this path will be the best, or it can be this path will be the best. So this is the loose method. Okay, understand? So let's start. Hops in ERO can be straight or loose. Straight hop must be directly connected. See here, straight hops must be directly connected. If the R3 R4 link goes down, R3 and R4 link goes down, R3 reset the path message because this neighbor is down. R3 tells router 1 to calculate a new path. And if my defined path has down, it will automatically revert to normal path by using backend IC. So there is no packet dropping. Okay. So when you use loose hops can be many hops away. It can be connected hops. It can be many hops away. Okay. I can define loose method or loose hops from router 1 and consider here my destination is router 10. If I mention the next hop is router 10 loopback, here we use loose mode or loose method. Okay. So there is the difference between loose and straight hops. So let's see. Configuring loose and straight hops is the part one. It's time for your first piece of traffic engineering configuration. So we want to check the traffic engineering, how to configure, configure loose, how to configure the straight. See here, set protocol MPLS path. This is the path, and you have to mention the path name. You have to mention the path name. Path name is user defined, and this is the destination. This is the destination. Here we use loose mode. Now I'm in router 1. I'm in router 1 and define the next hop. Next hop is router 8 loopback. So this destination is not directly connected. So we have to use loose mode. We have to use loose. And second example, set protocol MPLS path, then path name, then this is the path. And see here, the 1.9 is directly connected neighbor. So in that case, I use here is straight mode. Straight. So see, go to our topology. See here, I'm configuring LSP in router 1 and considering our this is my destination. This is my destination. Okay. So for this destination, that means for this loopback, I am far away from this router. So in that case, we have to use loose. If we want go to router 6 via router 8, via router 7 to last of router 8, it can be a path and it can be an alternative path. Multiple paths here. Okay. So let's see. Oops. Set protocol MPLS level switch path. This is another path. So you can mention here primary. You can mention here primary and the primary path. And also you can mention the standby path or secondary path. Okay. If first path is down, this traffic automatically shift to secondary or standby path. Okay. If standby path down, traffic will move to normal ICP path. No issue. Okay. Loopback IPs as straight hops. You can use loopback IPs in straight hops. It might seem like the next hop's loopback is not directly connected to the previous hop, but the TED is aware that the loopback is on that hop, potentially makes it easier to read your config. You can use, but recommended is directly connected next hop. Will be straight and remote will be remote neighbor loopback or for wire router IP will be the those. And see here, this is the active path, this is the primary path, and the straight is up. And this is the question and answer section. Which statements are valid about straight hops? For straight hops, the straight hop cannot raise out to the immediate next hop through different paths. This is the statement about straight hop. When a hop is listed as straight, the next hop has to be directly connected to the previous. Another condition. Okay. Under which hierarchy can you create your own name path? Protocols, MPLS path. Edit protocol MPLS path. Under the MPLS, you can define the path. And you can define multiple paths. It can be primary or it can be secondary standby path. Okay. So which statement enables you to add a name path to an LSP? Which statement enables you to add a name path to an LSP? Right. Now we discuss OSPF, how to popular TED database in WSP ICP. So it's simple, just enable traffic engineering under the WSP. Enable traffic engineering under the WSP product. That's very simple. Okay, nothing else. And they will make the WSP database. And the database LSA is opaque area. Is opaque area. Database LSA type is opaque area. This new LSA is generated when we enable traffic engineering under the WSP protocol. Okay, so this is the TE extension in WSP. Okay, show WSP database opaque area extensive, and this is the LSA ID and advertising data. This is the sample verification command. Okay, so loads and strict hubs in non-TE network traffic engineering. So, and another question answer section, which command verifies the new LSA. New LSA, which command verifies the new LSA. So, show WSP database opaque area will show you the new LSA information. Okay. What is the effect of the set protocol WSP traffic engineering? This basically enables the TE database in the WSP protocol. Okay, trigger the creation of series of LSA called type 10 opaque LSA. Type 10 LSA will generate it when you configure traffic engineering under the WSP protocol. So let's go to our lab, how to configure this one. Our discussion has finished. So let's go to our lab. First one is checking which ICP is configured here first. Okay, select. Right. So under the protocol MPLS, last day we create one LSP, and the LSP destination is router 5. LSP destination is from router 1 to router 5. There is no traffic engineering configuration here, and you can enable edit protocol ISIS. Any configuration is here? No. So we are using voice web, right? Edit protocol. Voice web. Show here. Set traffic engineering. Set traffic TRA traffic engineering. Traffic engineering and enter. It's a very simple command. Show now traffic engineering database is configured here. So this was set, and this command will become configured from router 1 to router 10. Every MPLS backbone router need to configure traffic engineering. Otherwise, we will not get traffic engineering database. Okay, that means TED database. So let's start. Route 1, 2, 3. Select, edit, router 2, and this is router 3. Route 1, 2, 3. Select, edit, router 3, and this is router 4. 5 and then router 6. Router 7, router 8, router 9, and router 10. 6, 7, good. So let's start. Need to configure same thing in every row. 3, 4, 5, 6, 7, 8, 9, 10. So comment this one. Okay, that's good. Now can check and show TED database. Okay, see here, TED database already created. And see here the name here, 1.1, that is coming from 1.2, that is 1.3, okay, that is 1.4, 1.5, from empty route. We are getting the database information from empty route. Okay, that's fine. Second one, we need to configure LSP. We need to configure LSP with straight and loose boot. Edit protocol, MPLS. Under MPLS protocol, run show, say here, output, run show, MPLS, LSP. The name is BMX1 to BMX5. See here, the status is up. And we're going to select extensive, extensive. See here the record route. So my record route first hop is 10.1.2.2. This is our first hop, number 1. 3.3, that is number 2. 4.4, this is number 3. 4.5.5, this is 5. Now, this LSP use this path to come from router 1 to router 5. So this is the automatic path. This is basically collect from ICP. Basically collect from ICP. Okay. So now we just modify the path now. Okay. How to do this? Set label switch path. The path name is BMX1, and we mention here 2. That means egress router information. We already mentioned the egress router information. So let's move our sample configuration now. Close and strict. Label switch path and the path name. Set MPLS label switch path name 2. This is the basic configuration. And we need to add path, primary path or a standby path or secondary path. Okay. And the sample configuration, yes, this is the sample configuration. Set protocol, MPLS path, then path name. MPLS path, then path name. So go to configuration, or you can see this from here. Okay. MPLS, set protocol MPLS, then you define here, see, we define here path. This is path, route of a level switch path. And you have to mention the path name. You have to mention the path name. Just for example, I want to send packet from router 1 to router 5, and the path will be this. Okay, path will be this one. Path will be this one. How to do this? Okay, so let's start. So, and path, we have to mention the path name here. So path name here be mx1 to BMX1 to BMX6. BMX6. This is the path name. BMX6. And you need to define the next hop. So this is our neighbor router is BMX6 and the interface is E0 by 0 by 1. So this plus say Z0 by 0 by 1. IP address is 6.6. So directly connected next. I mention here the next hop is directly connected. Okay, so here the mode will be straight. Mode will be straight. Okay, and next nothing. See here, set MPLS, then path, the path name, this is the path name, this is the path name, and this is the another path name. This destination like this. Okay. Sure. So this is the path. This is the path name. Okay. The path is 10.1.6.6 straight. Straight. So now set here. Label switch path. Label switch path is BMX to BMX5. BMX to BMX5 need to define primary. The primary and mention here the path. Primary path. So we already configured the path BMX1 to BMX6. I attach the primary path BMX1 to BMX6. Okay. So that's it. Now sure. Firstly, we create the path and calling this path in level switch path. Okay. So in that case, just commit this one back to our topology and verify the command. Show BGP MPLS show MPLS LSP name. The LSP name is, my LSP name is BMX1 to BMX5 extensive. See here, the record route changes. This is the time 15:13 and this is 13:06. First, this record route is generated and this was the active path. This was the active path and the path is router 1, 2, 3, 4, 5. But now the path is, the record route path has changed and the time is 15:13. 15:13. The path has changed and new path installed in traffic engineering database. New path is, first hop is 10.16.6. That is BMX1 to BMX6. The next one is 677 BMX7. Then 7.2. That is this path 7.2. 10.233 this path and 4.4 this path and last one is 5.5 this path. Okay. We send packet which is coming from basically which is forward to 1.5 destination. And this is our traffic engineering part. So in that case, we are using straight mode. We are using here straight mode. Okay. Okay. So now consider here router 7. Router 7. So you want path will be, this is your requirement. Second requirement is you need to travel this traffic. The path will be this. Path will be this. Okay. Router 8. This will be the path. And after coming router 8, they will go this way. So how to do this? Router 8 loopback is remote, away from router 1. So we need to define the next hop. We need to define the next hop using the loose mode or loose hops. Okay. So how to do this? So check this. So router 8 loopback is 1.8. Sure. Set path. We already defined the path. The path is BMX1 to BMX6. And intermediate interruption. So see here, we want to change the traffic path. We want to change the traffic path. The traffic path will be, see here, so traffic path will be, first traffic is coming in router 6, then goes to router 8, then router 3 to 5. So how to configure this one? So first, we configure here, define the path name, configure here the next hop, directly connected next hop, and the state hop. Second one, I'm now router 6. I want to go router 8. Which will be the best path? This path will be the best path. Because this consider the metric 1, metric 1. The total metric is 2. If I want to consider this path, the metric is 1, 2, 3, 4. If you want to consider this one, 1, 2, 3, 4. Again 4. So in that case, this path will be the shortest path. Okay. So consider this loopback, and this loopback is not directly connected with router 1. So this is far away from the router 1, and the mode will be loose, and the next hop will be 1.8. 1.8. Okay. So our configuration has done. Cover this one and check the verification LSP. See here, first record route or path is active path is this one. This is the first. Second, the traffic path is this one. And last, the traffic path changed. Router 8, then router 3, 4, 5. Okay. So you want to change traffic path based on your requirement. Okay. Okay. So thank you. Bye bye. Oh, in next class, we will discuss RSVP LSP bandwidth reservation. That is module 8. Okay. Allah Hafiz.